Hello everyone. In today's lesson, I just want us to continue from where we had stopped last time. Community marker to go and maka the introductory part of the topic electrolysis. So in today's lesson, tukufuna tingoona kwena kuti kodi electrolysis imachitika bwanji kakhala kwena kuti we're using the molten ionic compounds. And if you remember quite well in the last lesson tinaona kwena kuti ma melted kapena molten ionic compounds ndizonena kuti ma compounds oyena kuti it was a reaction between a metallic element komanso ndi non-metal, right? And then we had that thing, for example, in the case of sodium chloride, right? You can have anything like magnesium chloride and stuff, right? In as much as it is a combination or a reaction between a metal and a non-metal, and then if you were to split that, you going to my positive my negative ions. So in this case, if you were to melt, okay, it means going to mazi watch as many as jazo kapena kuti kandi nchere kandi chani mazo watch as many as jazo to the point when the melting point has been reached and yangofika popanga break, and then ma yili mu pala in form of pala in a way, and then it's containing those compounds, right? It's containing those ions, like in the case of sodium ions, komanso chloride ions. So in this, we're not using the sodium chloride, okay, but then we're using the lead bromide, right? So we would want to appreciate, of course the principle is the same. If you were to understand what happens if you were to use the lead bromide, it's the same principle if you were to use, let's say, sodium chloride and whatever it is, in as much as it is a molten ionic compound, right? So we need to pay attention to this, and wherever you feel I need to clarify more, please let me know and I will be glad to help. So this is the setup as it was in the previous lesson. For there to be, or the setup should be in this way, the battery, and the battery it is there to provide, like, the direct current, right? Because on its own, if it is not connected, that's the electromotive force EMF, right? So since it is connected, it is there to provide or to offer the a direct current. And we have the bulb showing that if this electrolyte, okay, if it is really an electrolyte or not, if it can conduct electricity, if it can be decomposed as electricity is passing through it or not, right? So if bulb it means yeah, I think this is an electrolyte of some sort. This is the switch. If you are to close it, means we are completing the circuit, so we end this whole sort of setup, right? This is the electrode. You might now graphite loads, and the good thing with the graphite loads, right? And sometimes I'm going to so like in exams when what is the advantage of using the graphite loads, right? The thing my graphite loads are inert in a way, then they do not take part in a chemical reaction. Immersed in this electrolyte, simapezeka kwena kuti iyo ikupanga release ma contents ake mu electrolytes mutakapenda kumanyenyeka, something like that, So we're using these graphite loads tolinga kuti to mix it to those terminals, and already if it is to the negative side, that's a cathode, but if it is to the positive terminal, it's called an anode, right? This is our electrolyte and it's called lead bromide. And to lead is in the group 2, and we know like bromine, the part they just need one electron, right? They just need one electron. So because of that, this one lead is in group 2. We know group is in group 1, okay? Because it needs only one. That's why we need two. We need more of two bromide, okay? Bromine atoms. So we're having PbBr2. Right, so we need to take note of this Pb, okay, and also Br2, because when we are writing the chemical reactions, like the half redox reactions to the actual thing, right? So now that we have this set up as we have seen, what really happens then ikakagwena kuti tayambapo kupanga, let's say the switch has been closed, right? So if the switch has been closed monga tinaona mujama, what happens in chonena kuti since current imakhala kuti ikuenda, it's ikudzera ku negative terminal ya battery jayo, okay? So it's coming from the positive terminal of the battery going to the negative terminal of the battery. Kapena kuti zingakwena kuti kuchoka ku negative terminal, like more of that, okay? Negative terminal of the battery. And because this negative terminal of the battery has been connected kuma wires oina kuti mpakana akalumikizidwa to the electrode, the graphite rod yomwe tikuitcha kwena kuti cathode. It means kwena kuti these electrons, since we've completed the circuit, the electrons will be moving from the negative terminal of the battery to the cathode, and cathode is the one which is connected to the negative terminal, okay? That's the thing, okay? So tifoena kuti this cathode yapangidwa immersed in this electrolyte nkatimu, okay? What will be happening ndijonena kuti these current is passing through the electrolyte, and because of that electrolysis will be happening. Lysis of the ionic compound which is in molten form will be happening. The decomposition, the splitting will be happening. Alright, so that's why in the liquid in that molten form, alright, ions azipeza kwena kuti akupanga move to the electrode of the opposite charge. Tifoena kuti current yapanga pass through it and yapanga decompose, and because this is lead bromide, it means kwena kuti we have the lead part which will have the positive ion, obviously, right? Because that's a metal, right? And we'll have the bromide which will be negative. And because there is that decomposition and the electrodes that we have are connected to the terminals of different charges, positive and also negative, even those ions that are in the electrolyte will be attracted by the electrodes of opposite charge. Remember, unlike terms attract, okay? So something like that. Unlike charges, attract positive and negative, positive, something like that. So in that case, it means the lead ions Pb2 plus, okay? Two electrons, right? So akala attracted to the cathode. Remember, cathode is connected to the negative terminal of the battery, so that's why this electrode negative charge. So because of that, it will be attracting these lead ions. And on the other hand, bromide ions, Br, and remember, Br ndiwena kuti yeu zingawena kuti anapanga receive ma ions, okay, ma electrons, so to say, okay, sorry. So because of that, since electron imakagwena kuti is negatively charged, in this case chomwe tikupeza ndiwena kuti ika Br negative, and because of that, because it is negative, it will be attracted to the anode, because anode ndi electrode yoti yalumikizidwa to the positive terminal, okay? So chifukwa cha chimene ichocho zikagwena kuti current kunani ikuyenda, because what will be happening ndiona kuti, okay, if you understand zomwe timanena kuti ma redox reactions aja, this will be pretty much easier, okay? Talumikiza the switch, we've closed that switch, right? What will be happening in moment now kwena kuti since ma charges osiyana zipangidwa attracted also to ma ions osiyana zipangidwa attracted to the electrodes osiyana ma charges. This is what is happening at the cathode, where that electrode, the graphite load, is connected to the negative terminal, right, of the battery, that is. Lead tifoyona kuti ndi Pb2 plus, okay? Yeyo apangidwa attracted, akapangidwa attracted chifukwa chonena kuti saiwale kuti ma electrons pajatika panga ujeni akumachoka from the negative terminal, monga tinaona apa kwena kuti ma electrons akuchoka from the negative terminal akupita kuti chani to the negative electrode. Zikuonesa kwena kuti if PB akubwera PB2 plus akubwera akukafika ku that cathode, ku cathode kuja azikalandira chani, azikalandira these electrons that are coming. My said so because these electrons are coming from that side, akafika kwena kuti akakumana ndi PB2 plus chifuna kuti 2 plus yo zikusonyeza kuti analuza ma electrons, and because of that akukumana ndi ma electrons amene akubwera from that terminal, right? Zikungoonesa kwena kuti azipanga claim back machana akaja ma electrons amene analuza when it was a metal. Okay, so remember tumeona kuti uyu ndi group 2 osonyeza kuti akuluza 2 electrons, and mwanjira ina since it's in a liquid form, not aqueous form, that's why tukuona kuti state yake ndi chani L, right? Liquid foena kuti angopanga melt. Uyuyu akakha kuti akakumana ndi electrode imene ijayo cathode ikalandira 2 electrons yomwe inatanija inaluza ija chifukwa kuti these electrons are coming from the terminal ya negative ya battery, and because of that izipanga claim back the state ya poyamba. Okay, so kusonyeza kuti since ababa ili mu form ya jani ilinga kuti mu madzi chifukwa kapena kuti mu chiphalaphala chifukwa tikhala kuti tindi PB kapena tindi lead koma osati kuena kuti ali mu form of ion yayi. Okay, oyamba anali ion koma atapita ku cathode wakalandira 2 electrons and wakhala jani wakhala liquid, and kusonyeza kuti mutakhala kuti mavula mojeni jayo muona ndithu kunena kuti ndi metal yomwe yapanga cover the electrode, mukakhala kuti mwaitani mwaicho samu mwacho samu ma electrode aja apezeka kwena kuti ndithu ku cathode kuja kwapezeka metal ya jani ya lead. So lead will be collecting on the electrode and izipezeka kwena kuti panga drop off kutiko that place. So because tinaona kwena kuti it's in both ways as well, right? Because on the other side where there is the anode, the positive terminal, that since it is a positive terminal, it will be attracting the bromide ions. And remember bromide timaina kuti uyu ndi ali mu group wena kuti mango panga 1 imango panga ima landila 1 electrode. So means kuti since it was combining with lead which was in a group 2, we were supposed to have 2 bromide ions. That's why in this case we have 2 Br negative. Okay, so because uyuyu alindi surplus yama electrons, okay, for the analandira ma electrons, so alindi surplus akapita kumene kujako kumene kuli anode chomwe chizilika ndi chonena kuti uyuyu aziluza 2 electrons. Okay, chifukwa yake pali minus here, so aziluza 2 electrons ndiku chomwe chizilika ndi 2 electrons uja akakha kuti wapangidwa lost like in this akafika uku kwa anode 2 electrons aziluzidwa, and this electron kapena these electrons azikhala kuti akuyenda ngati in form of ma current paka izibwera songa kuti kulumikizika zonse ngati kuti completing the circuit. So the only difference ndiyo nena kuti in this case we are no longer getting a metal because bromine is not a metal, is an nonmetal, right? That's why in this case you can't just have Br existing in the nature, right? Like bromine existing in the nature, it has to exist in a form that is more stable. So the form that is stable is Br2, which is bromide gas. Okay, so these Br ujen ions aja azikakuti awili akakakuti aluza ma ujen ma electrons ajao, okay, azipanga combine to form the gas which is Br2. So take note of the state, the chemical state which is yomwe akukhala nayo. So in this case we have G, which is gas, mapoyamba in a form of a liquid. So because of that, gas sangate kungokhala mu that pala here, because gas, remember, in terms of its density amakakuti ali less denser than ngati chiliquid chomwe chilipo. Because of that azipezeka kwena kuti that bromide gas azipanga bubble off, okay, and amene tikupeza kwena kuti tikakhala kuti sopano titalumikiza zinthu zonse both from the anode and both from the cathode. This is what we are going to have, right? Overall, that's pretty much what it is. Of course, we will look into the other lesson yomwe tikhale tikuona kwena kuti kodi chimachitika ndi chani, kapena kuti tizifunika tizilemba motani ma half chemical reactions and stuff. Komano, that's pretty much what we have in general. So this must be noted kunena kuti electrolysis yomwe ili mu molten compound, a metal is obtained at the cathode. Monga tinaona kuti lead timamupanga chani, timamupanga obtain from that cathode, right? Komano nani metal timamulandira fuchani to the anode, to the positive terminal, and to that positive terminal timatha kuona ndithu timababa kwena kuti tikutani tili mbali yakumene, koma kwena kuti mangopeza kwena kuti kutani tikulandirako ngati kuti tikupanga cover the metal, kapena metal ija kupanga cover the electrode yomwe tili nayo ija. Okay, nchifukwa chake tiona kwena kuti kusogolo kuti chimachitika ndi chani, kapena kuti ma application ake amakhala mu zinthu ziti ndi zitizo, right? Thank you so much guys for your attention, and whenever you need help, please just let me know and I will be glad to help, and keep on studying as well. All the best.